Now that the first 6 videos have demonstrated the steps you need to take to analyze the planar inspect data to come up with the time integrated activity coefficients for all of your regions of interest, I'd like to demonstrate the final step of calculating organ level doses. Now that we have these time integrated activity coefficients and also these volumes of each of our regions, we could use this information as input into the Olinda software. But this GUI does have a final sub GUI called the organ level dose calculation sub GUI. We get it through step 4 in the procedure menu, and that sub GUI will give us the same calculation that Olinda will give us without having to manually enter any data. So to do the organ level dose calculation, I'll actually go back to the sample patient 1 who comes loaded with the installation of JADA. This patient does have a complete set of organs analyzed, so it's better to use this for demonstration. So here we have the left and right kidney and the spleen and liver and a tumor for which we've calculated the time integrated activity coefficients. So this is patient 1. Also for this patient, there are replacement radionuclide time integrated activity coefficients calculated for iodine 131. So now that we have this patient loaded, we just go to the procedure, click on step 4, and our organ level dose calculation GUI opens up. Here's the layout. We have our investigated organs in a menu over here on the left. These are all of the possible source organs in the organ level dose calculation. These are the same source organs used by Olinda. And we just choose these organs one at a time. So we take the liver out of our investigated organs, choose the liver source organ radio button, and if we click add to selected region, then the liver time integrated activity coefficient ends up in this column, and the patient specific liver volume also gets entered, also gets used to calculate the mass of the liver for this patient. We can do the same with the spleen, add to selected region, and for the kidneys, since organ level calculations like Olinda combine the kidneys, we can do the same thing here. If we just press Control and select the left and right kidneys together, now when we add to selected region, it will put the combined time integrated activity coefficient and the combined mass of the 2 kidneys. So that's all we need to do, and we just go down to dose here and calculate, and if we look at the MATLAB command window, we see an output which gives us a total dose equivalent to the total doses you'd get if you were to input these time integrated activity coefficients and patient specific organ masses into Olinda. Just as one final example, remember we did calculate time integrated activity coefficients for iodine 131 for this patient, so we can actually repeat this calculation for iodine 131. We'll just save our technetium doses, and we can switch our radionuclide to iodine 131. Now when we add the kidneys, this is now the kidney, the combined kidney time integrated activity coefficients, and still the same kidney mass, of course. There's the liver time integrated activity coefficient for iodine, and spleen. And again, if we calculate and we go back to the MATLAB command window, these are the doses using iodine 131. Also note that we do have the adult female and adult male phantoms here. In this case, our patient is female, so this gets automatically selected from this pop-up menu. And we can save that iodine 131 dose calculation. And we've completed an organ level dose calculation. Next videos following this video number 7 will continue to show some extra features in the GUI, including the use of some more advanced segmentation methods in the process spec data sub-GUI, and also using the process spec sub-GUI to calculate voxelized doses.